Hey there, fellas. All right. So here's what I have to say to you guys. You know, it always used to be that we'd think of video ideas on our own, but as of lately, I've been reading the comments and, you guys and how inventive you are. Sometimes it can genuinely keep me up at night. But I mean, that's certainly a good thing. Now, you know what we should try doing? What if we were to weld up a crankshaft? We do know for a fact that certain automobiles, certain engines suffer from the crankshaft snapping in half. Usually people simply throw them away and install a brand new one instead. But now what if you were to try to weld it all back together? Well, we don't know, we've never tried it before. But I'd say it is definitely worth a try. Now, crankshafts, as we know, tend to be made out of iron. And iron is a material that is notoriously difficult to weld. The problem is that iron contains quite a lot of carbon. The number is somewhere around 0.75, if I'm not mistaken. So that's the kind of metal that falls under the term iron, and different sorts do contain different amounts of carbon, but when you're attempting to weld, carbon is always a huge detriment. You got big pores, the weld overheats, and that in turn leads to a lot of negative consequences. Okay, enough chit-chat, let's remove the crank, break it, or perhaps we'd be better off chopping it, since trying to break it we might bend it. So yeah, we cut it, weld it, reinstall it, and see whether it's able to stay in one piece. Let's do this. Fellas, big thanks for taking so many pictures with our merch. You want some drip like this for yourself? Then check out our latest collection of merch. We've got some trendy hoodies, some toasty vests, stylish hats and t-shirts, baseball caps to suit anybody's taste, mugs, stickers, and of course some goodies for your cars. Air fresheners, license plate frames, document holders, key fobs. Hit the link in the description to get yourself some Garage 54 goodness. Get yourself some merch and don't forget to use the code Garage 54, which is good for a solid discount. Welding a broken crankshaft, will it work? Translation and voiceover by BMI Russian. Here's how we want to do this. Now, the crankshaft is currently still inside the engine, and right here we've got an engine block. You can tell that it is definitely no longer fit for use. We had a piston fall apart inside and take out a big chunk of it. Anyway, so we're going to be using this block as a jig. So after we've cut the crank in half, we'll place the two halves into this block. Then we're going to have to secure them in order to keep them from getting warped. At the very least, to minimize it from warping, which it hopefully does not. Though if it does, we'll probably be able to knock out any curvature. Okay, so we weld it right here, then we proceed to extract it from here. After that comes time for putting the engine back together, starting it and doing some testing. It's all very simple, so let's get to it. Okay, we have removed the crank from the engine, and now we just need to figure out how to hack it. Now, the weak link on a lot of crankshaft is usually one of the main journals, which there are a few of here. Now, we'd like to try to keep this simple. Now, the middle journal on this crank does not have an oil channel, meaning that after we're done with the repairs, we won't need to drill a new one. It's not a huge problem, but we're short on drill bits at the moment. So we're gonna cut in the middle and weld it back up. We're gonna let Alexander do the honors. He's gonna smash it with an angle grinder. Yeah, and then I'm gonna fix it. Let's do it, just cut it right in the middle. Pick whichever spot you like and chop it. The crank is in place, and now comes the interesting part. Problem is, I don't know how to position it properly. It's freely spinning, and if we're off by even half a degree, that's going to result in unstable engine operation. The timing is going to be completely off, among other things, so yeah. We can try using some kind of measurement device, but I suspect that in our case, the best tool would be our very own eyes. So I've positioned it as best I could, and now is the time to modify our improvised bench with a bit of oil. We'll be using it to secure the crankshaft. I mean to pinch it. The thing is that if we try welding it while it's being held in place by just the caps, once we're finished, it'll most certainly be warped. The crankshaft is going to be all crooked. The whole point of this is to sort of displace the bearings. This one looks like it's from cylinder number 5. So we pluck out the bearing, clean it, and in between it and the cap, we insert a bit of foil. That's going to somewhat tighten the bearing, which will bite down on the crankshaft as to keep it from moving, most likely. Now that should be enough to keep it from warping once we proceed to weld it back together. Now we carefully fold it. The bearing is in place. Let's go ahead and install it. The whole thing does rotate, but I expect it to no longer be able to once we tighten all of the bolts. Let's find out if that stands true. Alright, even after tightening just one cap, I can tell that the crank is secure. I'm using all of my strength to get it to turn, and it just doesn't want to budge. Now let's do the same with all of the other journals, minus the one in the middle, and start welding. Now there has to be a better way to weld iron, but we're just not aware of it. A regular old MIG welder is what we'll be using. Some regular gas, carbon dioxide, not containing any sort of special additives. We've got it set to 24 amps, which is pretty much the maximum. Well, I mean, the whole thing is actually adjusted automatically. After all, this is not the ideal piece of kit for these types of jobs. But we're going to give it a try anyway. We're sort of making it a point to do a ghetto job. We've got a generous cutout going, so that's all looking really good. The torch fits very well, and this is going to require a couple of stages. So first I'm going to have to weld up the inner bits, then I loosen the caps and turn over the crank to weld everything up on the other side, and after that we finalize the welding on this, perhaps even with the crank removed. Now the important thing right now is to avoid touching the perimeter, so that later on once we have this on a lathe we won't have to cut off a bunch of excess material. Okay, let's get to work. Okay, we've welded up the crank, and even subjected it to a bit of grinding. We've removed any sort of crap, and honestly, this does not look all that great. I am not satisfied with my welding. It's not easy welding these types of items with a MIG welder. You've always got some kind of contaminants coming to the surface. Yeah, that's just how chemistry works. Cranks are made from high carbon metal, and with me using a normal sort of steel wire, the results are pretty atrocious. There's really no other way to describe it. I'm seeing a bunch of pores all around, and on top of that, there's a noticeable imbalance when gauging the main journals, to the tune of about 5 to 7 tenths, which is totally unacceptable, while the limit is 4. Well, at least according to the factory. In our case, we are well above that limit. And so, yeah, we'll have to weld this up all over again. There's still the matter of final grinding and polishing. And if we try to do that on this stage, we're gonna see a bunch of craters, and the crank is gonna be useless. So this is going to require some additional welding, and after that we'll be good to do a final grind. Alright, let's see how things are going. Okay guys, so look here. The welds, like I've already mentioned, it's rather difficult to weld iron, but we were very much able to. We've ground this down, everything is within the factory tolerances. Then we went ahead and used this here planer, which has some sandpaper stuck onto it. Unfortunately, we do not have a circular grinding machine. Hopefully that's temporary. So yeah, we used that to get this journal into this sort of condition. The scratches are very mild, but as you can see, we still got some tiny craters on the surface. They were quite large to begin with, but we filled them and kept on grinding. You know, in my opinion, this does not look half bad. Okay, the crankshaft is ready for installation. We've got close to no imbalances, so it's time to pull it from here and go place it into the engine block. After that, we get the engine fully assembled, at which point I hope it starts without any trouble. And after that is when the testing begins. Let's do this. Okay, we are looking pretty good here. We've assembled the engine with its welded crankshaft, we've got all of the associated components attached, even the spark plugs, though there are still a few connections to do up. Now for starters, the first thing we need to do is spin it up with the starter motor, in order to avoid a situation when we've already placed it into the car and it refuses to be spun up by the starter. Let's try this out. No, everything seems to be alright. Nothing has broken off. Now we need to get it some fuel, connect the ignition leads. Come on, spin it up one more time. Let's see whether it starts throwing smoke or steam. Okay, we've added a bit of gas into the carburetor. Now let's try starting it for real. Come on! Man, this is all over the place. How is it firing off so randomly? Since when is it a Subaru motor? After a few modifications. Okay, now it seems to be working fine. What, you scared? This is mildly scary, with this being a welded crank. So all in all, we seem to be looking pretty good. Everything is in perfect order. It works in this state, the crank has not yet shattered, and that makes me very happy. Now we slap it into a car, and it's out onto the road. For the testing part. But first things first, we need to install it into a car. Let's do it. Okay guys, this is all just looking lovely. The engine is where it needs to be. Now we can go try out the welded crankshaft. We are ready to roll. Clutch. Okay, we've got the engine running. Now we carefully begin to move. Let's try this out. Well, we were able to set off. That's pretty nice. Time to take this outside. Enough indoor driving. So the first 15 meters are behind us. So how is this going to be outside? Well, at the very least, we are moving. I've got the car in second gear. And so far, it's rolling. Very nice. It responds very well to throttle input. All right, the engine seems to be pretty happy to run on a welded crankshaft. Now, what's important is that we've done a good job with the welding. The pistons are reaching top dead center when they need to, and the car drives. With no apparent issues. Wait a second. We have got wheel spin. And right now I hear some kind of clicking noise, but that seems to be coming from the transmission or some other place. Wow, I mean, look at how much stress the crank is able to tolerate. It's transferring the torque with nary a hiccup. Holy cow, man. Now I suggest we try this out. That was the door rattling. After hearing a clicking noise, I was worried that something had broken, but apparently not.
Oi.
The ashtray just came flying out. Not bad. Cool stuff, eh? I take it the shocks in this are long gone. Here's where we're at with this, fellas. You'd think that the crankshaft being under such tremendous stress, with it transferring all of the torque to the transmission, also with it constantly being twisted, heating up, cooling down, and what have you. So there is a lot going on there, but nevertheless, as you can see, after welding together a broken crankshaft, now bear in mind that we welded the crank without heating it up or conducting any other sort of additional procedures, so there wasn't too much done in the way of preparation. Then we ground it down on a machine, gave it a quick polish, ending up with decent enough tolerances. Even the oil pressure value was more or less within the normal range, considering that the engine was far from new even before the experiment. So at this point it is considerably worn down. Nevertheless, the engine was still running just fine. It was able to cope with the stress of multiple burnouts, with me constantly revving it up. It just doesn't care. It lived through all of that. And so at the end of the day, if it so happens that your crankshaft has snapped, does this actually mean that you can weld it back together and continue using it? Well, that sure is what this experiment leads us to believe. If all of that torture wasn't enough to break it, then, hey, well, it looks like it's very much fit for use. I was really not expecting it to hold up. Again, iron is a very difficult material to weld. But in the end, we're looking at some decidedly positive results. My friends, this has been a tremendous experiment. 107% success with welding the crank, placing it inside an engine and driving around. It took everything we threw at it, which is just awesome. And that's all I got for you, fellas. Watch us, subscribe, suggestions, comments, big thumbs up. All right, catch you later.